All right, guys, we're in our last lesson of the week, and we're talking about calculating relative error. And what's cool about this lesson is, dare I say it, it's the first lesson that I will officially use a calculator to work out these problems. So this one requires a simple calculator, but if you haven't already gotten it, please get that calculator or get access to a calculator where you can use sine, cosine, and tangent, because that's going to help you to know how to work out the problems next week that we deal with trig ratios. Okay, so I have I'm going to be using my phone as my calculator, and we're going to be dealing with what we call relative error. Okay, this deals a lot with measuring. This deals a lot with science. This deals a lot with how far off are we when we measure things, or when we approximate things, or we estimate things. Okay, so for example, one thing would be, if I said the Earth's circumference is about, and here's the example, 24,000 miles. Okay, so I guessed, so my estimate is that the Earth's circumference is 24,000, and the problem that they go through, you go through an estimation. It's really cool. Like, each time zone, there are 24 time zones, and each time zone is about 1,000 miles wide. So if you have 24 time zones around the Earth, and they're each 1,000 miles wide, you would come with an approximation of 24,000 miles for the circumference of the Earth. And then measuring the actual circumference of the Earth, you come to find that it was 24,902 miles. Okay, so your estimate was this 24,000. Your actual was 24,902. Now, if I told you, for example, without even thinking of this problem, that you're 900 miles off, you would probably think, "Oh man, you're really wrong. You're really way out there." But the 900 miles off is relative. It was what we use relative. It means, are you talking about 900 miles off, like where I was supposed to go on my business trip, or 900 miles that I estimated Earth to Mars is? So it depends on what you're referring to with the 900, because 900 could be a lot. You're way off. I totally missed the mark. Or, I mean, it's like millions of miles away, and I'm only 900 off. That's actually pretty close. So that's what we mean by relative. It depends on the situation that you're dealing with as to whether 900 is really off or just a little bit off. Okay, so we're gonna find what we call the percent. Excuse me, the percent of error. A lot of us like percents because they help us to think of things very clearly. Like on your test, you really like when I put 95%. Instead of saying like you missed or you got 47 and a half out of 50, I put 95%, and you're like, oh, okay, I get that. So we want to see how far off you were with a percent, and that's what we're dealing with here. So how far is 900 miles off of the actual? So here's our formula for percent of error. We're going to deal with the measured value. So measured is my estimate, right? Measured value is my estimate. What did I measure it to be? What did I estimate it? And then we're going to subtract the actual value. Actual value. Oh, sorry, not a fraction bar. So the actual value. And we always get the absolute value of that. So it could be a positive number or a negative. So it could be a positive answer or a negative answer, but you have to get it to be positive. It has to be an absolute value. And then you're going to divide that all by the actual value. You're going to divide it by the actual value. So you're going to use that number twice. And then once you get that division going, you're going to multiply, and this is the hard part, you're going to multiply that. So your final step is you're going to multiply by 100. You're going to multiply that number by 100. And we're going to work out this problem here to see how that worked out. Okay, multiplied by 100. All right, so here I want us to look at, all right, our measured value was 24,000. So write this down, and then you can write it again, but with the actual numbers in there. So measured value is going to be 24,000 miles. And then the actual value, which is going to go on both of these spots, was 24,902. So 24,902, 24,902. Okay, so I have all the numbers where they belong. What I require in your homework is that you write down the numbers in this formula where they belong, and that you show me what your calculations are. So I don't want to just see your answer and you tell me, well, I did on my calculator. I want to see your steps. So my first step is to do 24,000 minus 24,902. And when you work that out, you get negative 902. But remember, we're talking about the absolute value. So you end up with 902 positive, and that's going to be divided by 24,902. And then don't forget, you're going to multiply that. So I'm going to do positive 902 divided by 24,902. And that gets me 0.03622199021. All right, I'm going to keep that number and just multiply it by 100. And I get 3.62219, blah, blah, blah. It just moved the decimal twice to the right. And so I'm going to round to the nearest tenth. So 3.6%. 3.6% is the percent of error. So you were 3.6% off, which is a 96.4 accuracy. I mean, that's really high. And all you did was you took the average length of each time zone to get at the equator to get the circumference of the Earth. So 3.6% off, man, you were 900 off. Yeah, but relatively, you were 3.6, maybe we'll say 4% off. That's actually pretty good, and we'll take that when we get that. Okay, so you're going to have those kind of problems where you get an estimate or your measured value, and then you compare it to the actual, and you'll see how far off you are. Obviously, the smaller the percent of error, the closer you are to the actual, and the more accurate you are. But it depends on what kind of problems you're dealing with. Okay, here let's do another problem, but this one's a little bit different because of how they write it out. It says find the percent of error. They also want you to find what we say the relative error, which is just the decimal form of your percent. Just do percent of error. Just do percent of error. So this one says find the percent of error of the area. And this is what they're going to give you. The measured area is going to be 42.5 inches by 68 inches. 42.5 inches by 68 inches. Okay, so they give you that. And then the actual is going to be 42 by 67.5. 42 inches by 67.5 inches. Okay, so you're like, whoa, this one's only off half an inch, and that one's also off half an inch. But how far are you off on the area? So that's what it's asking for. In the last problem, it just gave you one measurement for the measured, one for the actual. In this one, you're trying to find the percent of error for the area. So my first step is not to compare these two numbers and these two numbers. I'm going to find the area of this. It looks like a rectangle because of the numbers that they gave me. So the area of this rectangle, I have to do 42.5 times 68 first. So I'm going to do that, but I'm going to convert 42.5 into 42.5 and then multiply that by 68. And you can do that in your calculator. And I get a measured area. I'm going to put it here, 2890. 2,890. That's my measured area. So that's what I wanted to get first. They didn't give that to me. Then the actual area, I'm going to do 42 times 67.5. So notice I converted it to decimal again, and that gets me 2835. Okay? So if I'm trying to find the percent of error of the areas, then I have to first find the area of both. So this is how far off I was. Okay? So we're going to use that formula. So the percent of error. Okay, so we're going to have the absolute value sign, the measured, which was 2890 minus the actual 2835. And that's going to be over the actual 2835. And my last step is to multiply by 100. Okay, so those are the numbers and where they belong. So I'm going to do 2890 minus 2835. Okay, so I get 55. I was 55 off. And again, 55 sounds like a lot, but what are you talking about? Are you talking about you're 55 feet when you threw the football and you missed your target by 55 feet? That's really bad. But if you, threw or launched a rocket and you were 55 feet off your target, that's not as bad as it was throwing a football to a person. Okay, so here we have 55 over 2835, and then we're going to multiply that by 100. So 55, okay, clear out my calculator. 55 divided by 2835. Okay, that gets me 0.0194, and it keeps going. And then just multiply that by 100, and I get 1.9, and we'll leave it there because that 9.4, you just keep 9 the same, so 1.9% error. That's even closer than my last estimate was. I was 55 off, but I'm out of 2835, so I'm 2% off of the actual, which is really good. That's dealing with the area. You just multiply the two dimensions and compare those two values. You're also going to deal with volume, and this is this, guys, if you're listening, you'll know how to do this problem. There are a couple problems with volume, and what you do with volume is instead of giving you 2 measurements per measured and actual, they give you 3 measurements, and what you have to do with the 3, multiply those 3, multiply the second 3, and compare those 2 volumes just the way we did here on this lesson. So I hope it's not a hard lesson, and you get to use your calculator, but you still have to show me what we call your work, your justification, because if I don't see this right here, I'm not sure where you got that answer. Did you just copy somebody? I need to see what you thought through, how you got those numbers. So tonight's homework is going to be 2 through 12, numbers 2 through 12 even, and that's found in your book 281, 282, pages 281, 282. So don't forget you're dealing with just distance, area, and volume, so make sure you use appropriate measurements for that, and hope you do well in this last lesson of the week. Don't forget to get a calculator if you can for next week, as we're going to deal with some trig ratios. All right, guys, you take care and have a good one.